Okay, hi everyone, this is John Nichols, just taking you through a very short presentation actually. I'm sure you'll be pleased to hear, much shorter than other presentations I've done, but a short presentation on basic trigonometry and something I call the two-tick method, which is the approach I use to teach trigonometry pretty much every year. Now, yeah, this one's made a little bit shorter, so it's a little bit easier to digest, and also because the method's actually really quite short. I quite enjoy teaching basic trigonometry just because it's quite straightforward if you get them to stick to a routine. Admittedly, and I wanted to point this out straight away, admittedly this isn't great for understanding of what sine, cosine and tangent functions actually are. Yeah, the best way I think to get students to investigate what sine, cosine and tangent are really all about is to look at the relationship between similar triangles. There's a few worksheets which I can suggest for you if you want to do a little like investigation on what the sine function, cosine function and tangent function actually achieve. But yeah, this isn't really what I'm trying to achieve with a two-tick method. All I'm trying to get students to do when I teach them this is to find successfully a side or an angle of a triangle. So just apply basic trig. Okay, let's get started. So what I normally do before we start is, normally in the lesson before I start teaching it, I get them to write down SOHCAHTOA in their books, and I ask them to come up with a mnemonic so that they never forget how SOHCAHTOA is spelt. Naturally, I'm sure you all completely understand SOHCAHTOA is crucial to doing basic trigonometry with a right-angled triangle. Okay, you don't have to learn SOHCAHTOA, I guess, but you at least have to learn that sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. So SOHCAHTOA is the way most people achieve that, and well, really, you've then got to learn how to spell it, and if you do struggle with spelling it, and some students do, then why not come up with a mnemonic? Here's one which I've certainly heard before: some old hens cackle all hours till old age, but there's many others out there, and if you ask students, they'll quite often already know their own ones. I normally teach this in about year 9, so actually often that isn't the case, but certainly by year 12 and year 13 they've all got their own mnemonics for this, and quite often they're a little bit rude, so be warned. But yeah, anyway, they can make up their own, and as long as they remember it, that's a crucial thing. The other thing that students must be able to do before they apply this method is recognise the opposite, adjacent and hypotenuse in a right-angled triangle. Now, that I normally achieve in a day. It's not too difficult to do. To be honest, you'd be forgiven though for thinking that students would automatically be able to do this. Students can't actually do this straight away. They think they can, and they'll get most of them right, but there's times when they still get O and A the wrong way round if you just move the angle round. So try on, I normally do it on whiteboards. I get them just writing down O, A and H for any right angled triangle I write up on the whiteboard, and I rotate it round and I change where the angle is, and I just check that they all understand what I mean by opposite, adjacent and hypotenuse. The adjacent is what catches them out because they don't really understand what the word adjacent means in English. That's why sometimes alongside is used, because it's actually touching the angle, it's alongside it, and that sometimes is a bit more successful. But anyway, those two things are paramount before you teach the two-tick method, so make sure the students have got that sorted. Okay, so here is the two-tick method in all its glory. I'd like to point out I didn't invent the method. I got told it by someone I used to work with, and ever since then I thought, yeah, it's a sensible way for introducing it, because it's an algorithm, you know, it's just or it's a routine if you prefer. It's a routine for answering this kind of question. Okay, here we have a triangle. We have the hypotenuse labelled, and we have 500 meters facing the angle. Now, if we're asked to find the hypotenuse, what do? Well, I teach it like this. Step 1, label a side of the triangle you've been given, in this case O, opposite 500 meters, so 500 meters is the opposite, and label the side of the triangle you intend to find, and in this case we're going to try and find the hypotenuse, so label the hypotenuse H as well. So there should be on my diagram now an O next to 500 and a H, because that's the one I'm looking for. They might call it X in the question, but label it H. Step 2, write out SOHCAHTOA. Now, I often get them to write out SOHCAHTOA with the second letter, the fifth letter and the eighth letter raised. Now what I mean by that is it will say Sokotoa, but the O and the A and the O are all raised slightly, just to remind them that it's opposite over hypotenuse, adjacent over hypotenuse and opposite over adjacent. But you don't have to do that, but write out Sokotoa and then tick the two letters you've just labelled. So you're going to tick O twice and you're going to tick H twice, because we labelled O and H. And then quite simply, this is a two-tick method. Well, in step 3, whichever one we labelled with 2 ticks, and in this case it's the so part, not the ka, not the toa, whichever one we labelled with 2 ticks, that's a trig function we're going to use. So in this case we're using sine. This is just, as I'm sure you can see, a little bit of scaffolding to help them navigate their way through a trigonometry question. Now I always point out that after sin, cos or tan you write down the angle. So we've got sine theta is opposite over hypotenuse, everybody tends to know that. So sine of 12 is 500 over h. 500 goes on top because it's the opposite, h on the bottom because it's the hypotenuse. Now they sometimes still have problems with working out whether to times or divide here. You could just tell them letter on the, if the unknown's on the top then you times, if the unknown's on the bottom then you divide. I've sometimes shown them that, if I write 3 equals 15 divided by 5, then naturally I'm going to get, if I'm looking for the bottom number, I need to do 15 divided by 3 to get the 5. Perhaps that's better showing you on a presentation actually what I'm talking about there, but yeah, they should be able to rearrange that and come up with h equals 500 over sine 12, and hence the answer is 2,404.9 meters. And that's fairly straightforward. I'm certain you can all see what I'm driving at there. Okay, now the marvellous thing about the two-tick method, or the thing I like about it, is that it works for finding an angle in exactly the same way, pretty much. Okay, so step 1, this time we're going to label the sides of the triangle which we've been given. So we label the 12 and the 20 in this case. Now the 12 centimeters is clearly adjacent to the angle, and the 20 centimeters is clearly opposite the angle. So I'm labeling those A and O. Now, step 2 obviously is write out Sokotoa again and tick the 2 letters that we've just labelled, and we've just labelled the opposite and we've labelled the adjacent. So we tick the O's and the A's throughout. Once again, whichever one gets 2 ticks, in this case it's toa or tan, that is going to be what I'm using. Therefore I write tan theta equals opposite over adjacent. So tan theta is 20 over 12, because 20 is the opposite and 12 is the adjacent. And therefore, and this is one little bit of extra information you obviously have to give them here, we'll need to use the inverse of tan. They'll often see this function as shift tan on their calculators, but it's inverse tan of 20 over 12, and that's the way we undo a tan. And that just gives us the answer of 59 degrees. Now that's actually a little bit easier than the last one, because we didn't have to decide whether to times or divide, so they often find the angles a little bit more straightforward. Anyway, I hope that's a handy little refresher for how basic trigonometry works. Naturally, I'm sure you've all got your own ways of doing this, and please don't feel like you have to use my method. If you've got an alternative way to teach it, be my guest. I just wanted to give you an idea of how I taught it, and also I wanted to give you a little reminder of this kind of trigonometry, because it is certainly very, very important in GCSE and in A-level naturally, and it's got tremendous practical applications as well. Certainly anybody building anything would often use it. It's an important function for any kind of measurements. So anyway, I hope that was helpful and useful, and please let me know if there's anything which has confused you. You can always email me on john@archimedescollege.com. Okay, thank you very much. Bye bye.